Hey, welcome back. My name's Chris Wagner, Director of Data Solutions at Baker Tilly. This is Marcus Redu, Senior Architect and a Fabric Master. Today we're going to be going over querying your lakehouse inside of a notebook. Marcus, what do you got for us today?
Just what you said, Chris. We're going to go through how you can query that lakehouse via notebooks in Microsoft Fabric. We have a couple of examples and even how you can save those queries off into table objects within your lakehouse.
Woo, CTEs, let's do it.
Let's head over to my desktop here. So per usual, we'll start from the Microsoft Fabric homepage. And for today, I'm going to go to the Synapse Data Engineering window. And underneath that, we have a notebook prepared with some queries for today's demo. This notebook here, Lakehouse Fabric Query Demo. So I'm going to open that up. So you can see here, I already have a lakehouse connected in my Lakehouse Explorer. However, if this is the first time running or executing your notebook, you want to make sure, potentially if you're importing a notebook, that you remove all lakehouse connections if it's coming from maybe a different workspace or even a different resource that you're importing this notebook from. So a safe way, again, to remove all lakehouses and then add the lakehouse connection or connections that you'd want to execute this notebook against. So you can see here that I've added my BT demo lakehouse. And for today's examples, we're going to cover two ways or two languages in notebooks that you can use to query your lakehouse and even create a table object off of those queries. So the first example we're going to go through is via PySpark. So in cell 1, these are just some standard configuration settings that you'll want to do with these three commands here. So spark.config or conf.set. You'll notice here setting this vorder property to true. vorder is a performance enhancer within your notebooks that you'll certainly want to take advantage of. You may have heard of another concept called zorder that's available today in Azure Synapse or something like Databricks as well. That functionality is going to be coming out in the near future that Microsoft has talked about. So stay tuned to be able to leverage that. But for now, vorder is available, and you'll want to make sure you enable that in your configurations. So moving down to cell 2 here, and I'm going to actually kick off cell 1 so we get our session started and fired up. As always with Fabric notebooks, the spin up time for your Spark cluster compute is lightning fast. The session started, you can see in the upper right hand corner, 5 seconds, and within 12 seconds, my first cell is executed. So just outstanding performance by the Fabric product there. Moving down to cell 2, this is where I'm going to define my data frames, which are going to read the data from my lakehouse. So the name of my data frames are going to start with DF, summarizing data frame, and then underscore the name of that data frame. So DF sale, DF date, and DF store.
And DF's a pretty common naming convention that you'll see across different all sorts of different notebooks and tooling, right, Marcus?
Exactly right, Chris. So if you're inheriting code from another developer or engineer, most likely they're going to be using the DF syntax as well to describe their data frame or when leveraging a data frame. So you can see here to read my data, I'm going to use the spark.read.table command here. And the first part is you're coming from a SQL background. It's almost like describing your database that you're reading from, or your schema almost. So in this case, you can see I'm defining my BT demo lakehouse as the lakehouse I'm reading from. And then the table within that lakehouse, in this case, is sales. And I simply change that to date and stores for my other data frames. So ultimately, what I'm going to do is via PySpark, join those tables together and summarize some of the aggregate columns from my sales table and roll that up by date and store. So I'm going to go ahead and run cell 2 here to load that data into my data frames. Okay, we can see that that succeeded. Now, if I wanted to do a quick test to see if the data is actually in the data frame or what that data frame looks like, I can run a display command and I can put one of the data frame names in that display command and run this cell quickly for some debugging to see what I'm going to get. So you can see here, I can see the information from my sales table. And since I'm reading all the data, it's going to give me a preview here of what that is. I can even turn that into a chart without writing any code. You'll notice here I have a toggle between table and chart. And just like that, I can actually visualize the information that I'm returning in that data frame. So pretty cool that, again, with writing one line of code, simple display command, I can see both the table results and the visual results of that data frame. I'm going to comment that out for now. And in the output menu here, I can hide the output just to minimize that for now as I continue on. Before we move on to actually creating my joined data frame where I join the tables together and produce the final results, there's a different way. As with most programming languages, there's not one way to necessarily write the code. You do have another option for compiling your data frames. Again, if you're coming from more of a SQL background, you can use the spark.sql command and simply write a select statement from that lakehouse table to define your data frame and make sure that that statement is nested in double quotes here.
Okay.
So from cell 1 to cell 3 here, you can see that the syntax is slightly different. So I'm going to go ahead and run cell 3 here. And you can see that that cell ran much quicker, most likely because that information was already cached from running it in cell 1 here. So just keep in mind that there's different ways to collect that table information, or different ways to write that for your data frame. Now keep in mind, if I were to define the data frame differently in cell 3 here, like let's say I had some type of filter context in my select statement, or I only brought back maybe 3 of the columns from sales instead of the entire table with a select star, cell 3 is going to overwrite the information in my data frame that was collected in cell 1 if the data frame names are the same. So if I don't define a new data frame and I rerun it with a different context later on, it's going to overwrite the content in there. So just keep that in mind if you're doing testing or debugging in your notebook.
Do
That
you
would
get any errors if you're overwriting a data frame, or no? Does that just automatically happen?
Assuming it's the same name, it's going to automatically happen. Where you potentially would run into errors is if you were overwriting a table with a data frame that maybe had different column definition than the original table definition that you had saved, and you didn't specify the correct properties in saving that table, which we'll get to in just a little bit here in the next cell.
Okay.
So I'm going to comment this back out and just rerun cell 1. So now we're going to head down to cell 4 here. And this is where I'm going to define my final data frame, which is sale by date store. And this is what's actually going to be saved as my table in my lakehouse ultimately at the end. So the first couple of lines, again, I'm defining my data frame. I'm giving the data frames that I leverage from cell 1 here. These are the tables I'm going to be bringing in, some aliases. So that is lines 1, 2, and 3 here, these first couple of lines. So you can see df underscore sale dot alias, and I'm just calling that sale. Same thing for df underscore date and df underscore store, excuse me. Those are going to be aliased as date and store. After that, then I'm going to define my joins of the tables. So in this case, I'm using an inner join, and I'm saying that the join columns, in this case, date from sale and date from date, are going to join. And then below that, I'm going to define the store ID from sale and the store ID from store as the join columns there.
Okay.
Below that, then I'm going to select the columns that I want to bring in my query. So you can see on line 4, that dot select. And you can see this is where those alias names come into play, where I can simply name those columns with the alias that I've defined above, and then the actual column name from the table that I'm bringing in. One point I forgot to notice, or call out, I should say, is to continue your statement, but keep it separated by lines. Using a / at the end of your line will continue the statement down in your cell. So
Okay.
this is really one long statement that's being executed, but for readability's sake and best practices when writing your code, breaking those up into different lines based on the different commands that you're doing in the statement is a best practice. So leveraging that / to kind of break it up would be recommended there.
Okay.
Since we're doing an aggregate in this statement, I do need a group by. So after my select statement, I'm going to define the group by columns, which is essentially going to be all the columns I'm not summing up or aggregating in this case. So that can be as simple as doing a copy, paste, and making sure that you use the dot group by. Next, I'm going to sum those aggregate columns. So in this case, units, revenue, and cost. And then below that, I'm going to rename those aggregated columns to total units, total revenue, and total cost with this dot with column renamed command here. Finally, I can add an order by statement, and I'm going to order by date, store region, and store state. So this is my data frame command. And before we actually save it as a table, I'm going to comment the save line out here on line 12 and just run this data frame. And then to show that data frame, again, we can do display sale by date store. And we could quickly check those results of what was produced from that query and make sure that's the data we want to save to an actual table in our lakehouse.
Wow. So we can create this table and then use this for future reports and like as like a silver layer, or if we were creating a gold layer. Is that right?
Exactly right. So as you're transforming your data, maybe from the base tables that were made available in your lakehouse, being able to aggregate that and or transform it in a different way and save that back to your lakehouse for reuse. Absolutely, Chris.
A question for you, Marcus. So this is PySpark that we're using, and this is how we write a query. And so it still has the select from where inside here, but it's in a very different format than classical SQL. Is it possible to do the same thing with more SQL based syntax?
It sure is. And then we're going to get to that in our second example shortly here. So yeah, absolutely. If you come from more of a SQL background, you can use traditional T-SQL syntax directly in your notebooks.
Okay, cool. So we have two options. This is a first of them.
Correct.
So
I'm
if
going to
you're
go ahead.
watching and you're very afraid, like, oh no, I know SQL and I don't know this. This appears like a lot. It's going to be okay.
Don't worry. Help is on the way shortly.
All right.
So finally, we're going to take that result data frame or final result data frame, and we're going to save that back to our lakehouse. So getting back to Chris's earlier point of, could I run into an error saving my data back to my lakehouse in a table format? You could, unless when you're writing that data back, so you can see I've selected that data frame, sale by date store. I'm selecting overwrite as the write mode. Okay, so we're not saving historical results in this. We want the latest results that this query is returning. The format, I'm saving it as a Delta file. Again, you do have different options for saving that back, such as Parquet or CSV are examples of that. This is where you can avoid that error. So in the dot option, you can say overwrite schema. So what that means is it's going to take the latest version of the schema in that data frame, and it's going to say overwrite anything that exists by setting that to true. If you didn't want to overwrite your schema and you wanted to merge that schema into what's already there, you would define merge schema here in that option instead of overwrite schema. And in the write mode, you would actually put in append instead of overwrite. So those would be the two changes if you wanted to merge data into an existing lakehouse table instead of overwriting it.
Gotcha.
And then finally, we're going to do a dot save, and we're going to give a location in our lakehouse. In this case, we're just going to save it in the tables menu, or the tables folder, excuse me, and give it a name, sale by date store. I'm going to go ahead and execute that. And if I refresh my tables menu, I should see a new table here, sale by date store. And I can see my columns defined from my data frame here. And if we click back to, we navigate back to our lakehouse here. So here we can see now querying our lakehouse back in the SQL endpoint view, we can see the results of that new sale by date store in our lakehouse. So pretty impressive that we can take a query running against our lakehouse in PySpark, create a data frame, and then save that off as a new table in our lakehouse.
Wow. I mean, that's fantastic when it comes to like how we bring data together to provide consistent, reliable insights. Be able to persist those queries is key, right?
Absolutely. Nobody likes rework. So anytime somebody discovers some valuable analysis or insights that they want to share with others, the ability to save that and reuse that in reporting or your ad hoc analysis is invaluable. And Fabric makes that super easy.
That's awesome. Now you said I'm gonna hold you to it. You have a notebook that shows us how we can write just regular SQL and do the same thing.
Sure do, Chris. So we're actually going to hop back to that same notebook that we were just in, the Fabric Query demo. And hidden below, we have a second approach to creating a aggregated table in our lakehouse. So approach number 2 that we're going to talk through is Spark SQL. So this again is the ability to leverage traditional T-SQL syntax directly in your notebook. So you'll see here in my cell, I've changed this to a Spark SQL cell. Again, you can do that either through the double % and then SQL, or the lower right-hand corner of your cell, you can click the toggle to change the language of that cell as well. So in this cell, I'm going to, instead of creating a data frame, I'm going to create a temporary view to store my aggregated results. And then I'm going to create a data frame from that temporary view and save that off as a new table in my lakehouse.
Okay.
So if you want a refresher on T-SQL syntax, go back and watch some of our previous videos where we stepped through some of the basics of T-SQL and even some of the more advanced concepts that you can do with T-SQL and kind of the order of operations that you would have when writing a select statement. So you can see here I have a select statement where I'm defining my columns and also my aggregates similar to what I did above, except in this query, we're going to summarize it by the sales by date and sales rep instead of by date and store. So I've changed out the store attributes for my sales rep names. The tables I'm bringing in are sales date and sales rep, and I'm doing inner joins on those just like I did above with the date and store tables in my previous example. Going to do a group by statement again for those attributes that are not being aggregated. And finally, an order by statement for date and sales rep in my results. So I'm going to go ahead and run this cell here. And then below, I'm going to take that result again from that temporary view. So this name here, sale by date, sales rep, going to do a select statement with that spark.sql command. And I'm going to save that as a new data frame here. Sale by date and sales rep. And then I'm going to write that data frame to my lakehouse as a new table. But again, just to show kind of the different steps here, let's break this statement out. And see our results of this new data frame. So I'm going to run this data frame here, collect that select star from that temporary view. Then I'm going to display those results to make sure that that data looks like what I want to go into the table. And we're going to hide that output again. And then finally, we're going to do that write mode again, overwrite as my mode, format delta table, option overwrite schema true. Then I'm going to save it with a different table name, sale by date and sales rep.
Wow, that's
Okay.
so fast.
Super fast, 5 seconds. And look at that. If I refresh my tables menu in my lakehouse, I have my new table here, sale by date, sales rep. I can quickly toggle back to my lakehouse view, SQL endpoint. And I can see that sale by date sales rep, and I can see the information that has been returned with that result.
Oh, very cool, Marcus.
One last point I want to call out is, let's say for some reason you created a view, saved it as a table, or created a data frame, saved it as a table, and it ended up not being the results that you wanted. So you wanted to blow that away or delete that in your lakehouse. A simple cleanup command here, also using traditional T-SQL, again, making sure that this is a Spark SQL table. You can run this command, drop table if exists, and put in your table name that you just created. So if I run that cell and I refresh my tables,
Awesome.
see refreshed, that sales by date sales rep query is no longer there. And we can comment that back out to keep that in our notebook if needed.
Wow. I mean, that's fantastic. So just to summarize, really easy for anyone, whether you're working in Python or if you're working in Spark SQL, to create queries that access data inside your lakehouse from within notebooks, and even then persist them in tables that are registered and available for others to consume in your notebooks, right?
Absolutely, Chris. As we've shown here, two relevant, fairly easy examples to either leverage PySpark or Spark SQL in your notebooks to create those table objects and transform or aggregate your results in your lakehouse.
Awesome. Well, Marcus, thank you so much for showing us how to do all this. Super excited about all these capabilities now are accessible to anyone. If you have Power BI or Power BI Premium, or even just a trial of Fabric, you can go in and use those today. Oh, how wonderful, Marcus. Thank you.
Not a problem, Chris. Thank you.
All right, everybody, have a great day. We'll see you next time.